Hi guys, I had a couple of requests to go over this problem from today's work. Thanks Francesca for letting me know, and some other friends too who chimed in at our 11 to 12 o'clock meet. So we're going to go over this one. I already started highlighting some of the important information and I read it a couple times to myself. So the work crew spent 4 days paving a stretch of road. The table below shows the length of road paved each day. So on Monday, they paved 5 miles and 5/6 of a mile. Tuesday, 6 miles and 3/6 of a mile. Wednesday, 8 and 4/6 of a mile. Thursday, 4 and 1/6 of a mile. The entire length of road will be 27 miles. What is the total remaining length of the road that needs to be paved after the 4 days? I highlighted the word remaining because that tells me that we're going to figure out how much they paved Monday through Thursday, but remaining means there's going to be something left. And that's the question they're asking, is how much is left to be paved after the 4 days? So I'm going to start by writing down an equation to represent how much they paved Monday through Thursday. And I'm just going to write it as it is right now, and then we'll do some step-by-step work. So Monday, 5 and 5/6. Tuesday, 6 and 3/6. Wednesday, 8 and 4/6. And Thursday, 4 and 1/6. Now, there's lots of things that you could do here, but what I think is a good way to start is to go ahead and add together all of the whole miles that they paved, because that just makes it easier when we're looking at the fractional pieces. We can look at the fractional pieces separate and away from the whole miles. So I'm going to go ahead and just add these up. So 5 miles plus 6 miles plus 8 miles plus 4 miles. Those are the whole miles. 5 plus 6 is 11 miles. 8 plus 4 is 12 miles. So 11 miles plus 12 miles. 23 miles. All right, so 23 miles is how much they had paved Monday through Thursday, only looking at the whole numbers. Now we can't stop here because we have all these fractional pieces, and we have to do the same thing. We have to add those up and find out how much those equal. Otherwise, we're sort of missing a whole bunch of the road. So I'm going to write those down also as an equation. So 5/6 of a mile, that's that fractional piece, plus 3/6 of a mile, that's this fractional piece, plus this fractional piece, so 4/6 of a mile, plus 1/6 of a mile. Now, you probably learned from watching today's Edpuzzle that we can add these pieces together we can add these pieces together to get a total amount. But we can also use our rectangles to show what each of these fractional pieces represents. So I'm going to do a little quick drawing for each of them and just show what they really represent. Okay, so I have my rectangle here that has 6 pieces, and to represent 5/6, that would mean 5 out of 6 of those pieces. 5/6 are shaded. Now, I'm noticing that this is almost a whole, but not quite. Now, I'm going to represent 3/6 here using the same size hole and also cut into 6 because nothing has changed about our denominator. All right, 3/6. Here, I'm going to represent 4/6. Again, showing 6 equal pieces as best you can, and shading in 4 of them. Okay, and then last we have a 1/6 size piece. Great. Okay, so now what I have to do is I have to add all of this together. How many sixths do I have? 5 sixths plus 3 sixths is 8 sixths. 8 sixths plus 4 sixths is 12 sixths. And one more sixth is 13 sixths. I have 13 pieces that are all 1/6 size in total when I add these together. Now, like you heard Miss Emily talking about today in the video, yes, here we have something that looks a little strange. We call this an improper fraction. An improper fraction is one where the numerator is larger than the denominator. When we're looking at an improper fraction, we're thinking, is this, well, when we're looking at any fraction, particularly in this case, when we're looking at it, we're thinking, is it less than 1? Is it equal to 1? Or is it more than 1? Yeah, in this case, it's more than 1. We have 13 pieces shaded, and those are 1/6 size pieces. I know that 1 whole, in this case, is 6 sixths. I'm wondering, can we make 1 whole from what we have? Do we have 6 sixths? Yeah, we do. 6 sixths is a 1 whole size piece. Do we have 6 more sixths? Could we make another whole? What if we had another 6 sixths? How many pieces would that be? 12 sixths, yeah. Interesting. So we can make 2 whole rectangles using 12 sixes. Will we have any more pieces? How much more will we have? If I have 6 sixths plus 6 sixths, that's 12 sixths. How many more pieces do I have left? Yeah, 1/6. All right, so I have 2 wholes and 1/6 left over. So 13 sixths equals 2 wholes and 1/6. If you want to think about it like you're combining some of these pieces to make wholes, here's what I was thinking. If I took this one piece and I moved it here, the 5 sixths and the 1/6 would create 1 whole when they are combined. Okay? Then we have 3 sixths and 4 sixths. If I took 2 of these pieces, here, let me use a color. If I took 2 of these pieces and I moved them into these 2 open spots, then this would be a whole. And then I would see that I only have 1/6 left. So that's just a way to, if you're having trouble thinking about what we're saying, to show that we would have 2 full rectangles and 1/6 left. All right, so now that we have figured out what our fractional pieces are equal to, we're still not actually at the answer yet. This problem is very lengthy. So we had 23 full miles. And then we just figured out that these fractional pieces were equal to another 2 miles and 1/6. So we have to add that together. If I have 23 miles and 2 more miles, then how many miles do I have? 25 miles. And we'll bring that 1/6 back over too, because we can't just get rid of it or ignore it. All right, so last step is figuring out how much further, how much is left for them to get to 27 miles. All right, so Monday, Tuesday, Wednesday, Thursday, they have paved 25 miles and 1/6 of the road. 25, sorry, I'm running out of space here. 25 miles and 1/6 plus something will get us to 27 miles. First, I want to think maybe about adding something to see how close I can get to 27. I'm thinking if I add 1 full mile, then that will get me to 26 miles and 1/6. All right, 26 miles and 1/6. I only need a little bit more to get to 27 miles. If I have a hole and I have 1/6 already taken care of, how many more sixths do I need to get to 1 hole? I would need 1 more 1/6, 1/6, another 1/6, another 1/6, and another 1/6. All right, maybe you can see here, how many more 1/6, how much more would I need to add? 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. I would need to add 5/6 to now have a hole. So the answer that I got for this question was that they need to pave 1 5/6 of a mile more. So I would go ahead and write that on my answer line. 1 5/6 miles. All right, I know this was a tricky problem. It had a lot of steps. I hope that maybe I was able to explain a little piece of it. Even I found myself struggling for how I was going to explain this clearly. So do your best. I think that our work today on adding fractions is definitely something to remind yourself of and keep going back to and reviewing if you're not sure. Always helps to draw a representation, and so I think that can be a good tip as well. All right, talk later.